I welcome Dr. Patil,
Okay.
sir, to please start with the session.
Yeah. Thank you. Thank you, Prisha, for this introduction. And I'm welcoming all the participants who joined today. Even there is a Saturday, I can see there are many guys and many people who is interested in participating this program. And I'm thank you, Mr. Nitesh and Team FCP, to give us a forum where we can share our knowledge. So I'm just presenting my screen, so that will help to see the content of the presentation. Give me a second. Just it is loading. Since file size is large, it may take certain delays to load it. ओपन कर ओपन व्हील किया
Sir, so, algún bloque de ahorita.
Okay. So hope my screen is visible to all.
Yes, sir, it's visible.
Okay. So welcome all, and this the topic for today's discussion is impulse testing and validation of hydraulic hoses and hose assemblies. Okay, so this is the agenda. Uh, so initially, I will introduce about the laboratory as a fluid controls and the whatever testings we do for the hoses and allied products. Then a bit introduction about fluid controls and FCP as a organizations. Then the testing of hoses and sorry, am I audible to all? Nitish ji?
Yes, sir. Yes, sir.
Okay.
Very much
So
audible.
yeah, then we'll go into the detail about the impulse testing and various criteria for the impulse testing, and then maybe post to it they will open for the question and answers. So you can park the questions into the message box interim period. So I will just take you through overall agenda, and then maybe finally we'll take each question independently. Okay. So regarding the fluid control as a laboratory or as an organization, this organization is a value-based organization, and the foundation of this company is basically an innovation. So whatever innovations we call it, is we are in this segment for more than 50 years, specifically into the hydraulic pneumatics, uh, predominantly started with the instrumentation, where there is a measurement and uh, allied pressure, high pressure, low pressure, even vacuum application products we have developed. So innovation is one thing which is apart from uh, only the product. What we offered is that services, the value added engineering. So that is our core foundation of this company. From day one, we basically focus on it. We developed many technologies independently, and it is been widely used not only in India but worldwide as well. Since as a fluid control technical solution providers, as a solution providers, our our reliability has been proven throughout the decades. So when I say reliability, basically this is the consistency. Whatever we offer as a product, as a services, whatever we do, we are quite reliable, and that is being accepted by many organization, esteemed clients all over the world. Uh, and the topmost value, what we deliver throughout our organization to whoever be basically stakeholders, is integrity. So when I say integrity, integrity is one thing which we commit as a voluntarily throughout the organization, and for that we have a certification, voluntary certification, that is anti-biology management system. That is one certification what we hold, as we see that there is a oath which has been taken by us, customers, vendors, employees, and shareholders. So what is the topmost value we feel that we created? Uh, so this organization or testing laboratory is a value-based organization. As a FCP index, yes, FCP index uh, is a is an organization being formed by a professionals having vast experience with the global companies, specifically in hoses, pipe assemblies, or many industrial products. That is Gates India, Parker, Hanfin, Faster Hydraulics, and Aero Cube. So those are the leading names in this segment. So we are associated with FCP index from many years, and we keep on interacting with each other. We basically uh, discuss on many topics across the industrial problems, and we help each other uh, to see how we can help industry to uh, solve their current complex problems. The main objective of FCP index is basically giving the guidance, actionable solutions. Those are the practical solutions, not only the companies, but the individuals who are basically starving to get excellence into that field. So that is the motive of the FCP index. And the strategy is always a win-win strategy where both or either parties would be having the win-win situation. As a fluid controls, as I said you, it is founded in 1974, and we are basically known as a in-house R&D center. Not only as we declared as our own R&D centers, but Government of India and Department of Science and Industrial Research, primarily it is known as DSIR, that certified us from last 9 years that okay, this organization is having their own capability to develop the product, to test the product, and that's what we we are basically proven enough to uh, to to discuss with our clients or to the interested folks about from concept till the commissioning. We can help to many organizations or individuals. The laboratory, whatever we basically doing the testings, it is not limited to the national and international standard, and that's what this laboratory is approved by the NABL as well. Primarily, this company started as a connector experts, but more than the connectors, we are the solution providers. As I said, you as the values, we drive with the innovation. So The prima facie, this we basically R&D as a separately focus on it, and that is formed to give a product with the competitive advantage and do the innovation from the scratch. So that is the main motive of the fluid controls laboratory. We also provide a solution for uh, FE analysis modeling. So that is the core concept what is been mechanical products so far developed. So we have advanced softwares for it, and predominantly we known experts into the oil and gas, process, power, and railway industry. So that is our main focus area. Of course, now we are basically enhancing our capability to uh, aerospace and defense market as well, and we are doing good into it. So that is the thing what we enhance our capability to cater to the
तो
most
उसको कैसा
demanding
लगा बॉय
industries.
को कैसा लगा माँ
Okay. So along with the product development, along with the services, along with the offerings, this organization is and laboratory is certified with ISO 9001 2015, ISO 14001, and ISO 45001. And there are 150 plus product which can be tested and certification is been done throughout the organization so far. Okay, this is about history of the fluid control or main driver of the fluid control along with the FCP index. So this company is started by a doctorate in mechanical engineer person who studied in Northwestern University. His name was Dr. Y.E. Muchalla. So he started this company way back in 1974 to solve the complex instrumentation parts and solution to the industry. Currently, it is been driven under the leadership of Dr. Tansen Chowdhury. So Dr. Tansen Chowdhury is the CEO and managing director of this company and laboratory. Basically, he holds a mechanical PhD from IIT Bombay, and Mr. Amrish Chatterjee, he is also uh, having a 35 plus experience along with the IIT Kanpur. He is oneself is the uh, hose expert or hose doctor as an interim. So Mr. Amrish Chatterjee and Mr. Dr. Tansen Chowdhury help us to solve many industrial problem uh, with their keen interest. And then Mr. Nitish Kitare is the main driving person who is expert into the mining engineering, and he worked with esteemed organizations across India, and he helped us to basically develop many avenues in these laboratories. Myself, Dr. Rahul, basically, I'm a though I'm associated with the management degree. Prima facie, I'm a uh, love to do the technical things. So this laboratory and all those things is been driven along with Mr. Anup Pillai and Dr. Ganesh. So Dr. Ganesh is basically again a metallurgy PhD, and he helped into the overall laboratory to take it to the next phase. Along with the Ganesh and Mr. Anup and who are made the team from the laboratory, there are 35 experienced engineers and technicians who dedicatedly work in our laboratory. So starting from 1 year experience till the 25 experience, there are experts across the industries who help us. So altogether, if you see, there are 100 plus experienced guys who basically dedicatedly put their effort to make this laboratory operation uh, to the tune of national and international level. So this is the team behind the laboratory. Okay. So this is the snaps photos of the laboratory. We are basically uh, having a head office in Mumbai, Churchgate, and we have a laboratory in western part of India, in state of Maharashtra, Pune. This laboratory is spread across 1,25,000 square feet. Uh, and we also having the agents who can help to international clients across India, Europe, USA, Southeast Asia, and Middle East. So there are many testings which we do for from Asia, Europe, and USA as well. So that's what this laboratory is truly can provide us testing services for globally as well. Okay. So apart from whatever testings, before start of the testing, as I mentioned during my introduction, that this laboratory is certified with the DSIR, NABL, and ISO and EHS certifications. So whatever we do, the safety comes first. So we basically having the all the practices set through the EHS environment. So we take utmost care for safety as a first, because we are into the high pressure and high temperature segment. So there might be certain critical aspects during each and every testing. So we have to, our first and foremost effort is to make the safe environment for testings. And as I said, when I say NABL, there are many NABL testings which is been first time approved by NABL for exclusively for fluid controls, and not only for the application like oil and gas and automotive, but for aerospace also. This laboratory is catering to the world's tier one companies like Boeing and Airbus suppliers to test their hydraulic and pneumatic products. So that kind of setup also we have, and that is basically being used by many national and international manufacturers. So apart from the certifications, we also cater to the many industries like railways. So we have the International Railway Industry Standard Certified Organization. We deal with the many European organizations. So there is a PED 9723 EC certification also we hold. As I mentioned you, there is a laboratory certification. We also having the AS 9100 for aerospace quality management system certification. Since aerospace is a very highly critical application and highly demandable in terms of quality and reliability. So there is a certification called as a NADCAP, that is specifically in terms of fluid distribution system. Our laboratory and operations is basically certified under the NADCAP. And as I said you, integrity is the utmost value. So voluntarily we took ISO 37000 certification, that is anti-bribery management system certification. And predominantly, Pune is the location where most of the automotive OEMs and automotive component manufacturers, as like also we also do a lot of products for CNG and other segments in the automotive. So we hold IATF 16949 certification. And there are many 150 individual certification with respect to the applications, which we keep on adding every year. Or as I can say, with every customer, we try to see whether with their demand and with their application, we uh, strategically allied together and we develop exclusively customized certification program for them that will help to get many benefits to them to enhance their product performance, or to as a competitive advantage, we can help them to get their certification program as well. Okay. So what different from conventional laboratories as a fluid control? You can see in the previous slides, as I mentioned, our specific expert area is pressure, flow, and structural analysis. That's what we are experts into, and we are doing it from decades. We have environmental testing chambers specifically for low temperature, high temperature, and corrosion as well. So that can be simulated across all the products, or whatever environmental requirement, like environment also can be created into our environmental testing chambers. We already testing global OEMs products. So nationally and internationally also we have the presence. We can help many OEMs and many manufacturers across all the globe. Uh, and we are not alone. As I said, there is a brain behind each and every activities what we do. So we are basically having the industrial and academic partnership with the premium institutes from India. There are 100+ students keep on coming to us. They complete their internship programs, even they do the research along with us. So there is out of box thinking also keep on happening at our place, and that's what we create a space for many new upcoming people or students to get into the industry. We also having the industrial and government laboratory associations like FCRI, ERI, DRDO, RDSO, NPCL, Indian Navy. So we keep on participating with them to solve critical problems wherever we are expertise and wherever their need is. So there are many success stories across along with this organization we proven to them. We also open to lies with the OEMs. In fact, many OEMs and their tier one suppliers lies with us. And this laboratory has been also validated along, apart from the certification and accreditation bodies, there are many TPIs and accreditation agencies like QUV, DNV, BV, and HGS. And there are customer specific witnesses also been performed at our end. So our laboratory and people is very worked with uh, those agencies. Uh, so there are specific testing segments like we can do the CA evaluation, like CFD and structural analysis we can do. We have the softwares, ANSYS, where we can do this. And of course, there is experience and dedicated team who handles basically this separate CA evaluation, which can give you which can reduce your number of trials, testings, prototype testing theoretically as well when you wanted to use that kind of service as well. We do the metallurgical testings, so chemical, mechanical, whatever testings are there in terms of metallurgical testing, even spectrography, micro hardness, intergranular corrosion kind of testing also we do. We also having the separate non-destructive testing experts like DP, PT, MPI, and leak testing. We have the experts and facility where we can do the testings. We are open to discuss with the customer to develop their test programs specific to the application. And our expertise as we are working with automotives, railways, oil and gas, power, aerospace and defense. And in fact, we have a clean room, which is a 1,000 class clean room where we can even test medical and pharma and process industry product as well. And that's what the fuel components where there is a highly demand for the cleanliness, we can do the testings in terms of clean environment as well. And we participate into the validation. We can do the fundamental research. We can do the new product development along with the team or wherever there is a need. Okay. So I will just, I will not read all those tests, but yes, you can see over here, any product in terms of validation before it is to be tested with respect to the actual impulse testing, or we call it as a fatigue testing. In the fatigue testing, maybe impulse, vibration, thermal, whatever may be the simulation you need to be. But before that, product has to undergo various sequential testing. Like prima facie, when we do the product, at least we need to do certain initial testing like proof pressure testing, hydrostatic burst testing, pneumatic pressure testing. So before putting it to the actual fatigue testings, we need to do or we need to carry out different testings. So this testing also we covered under the NABL. So like if you wanted to do a host testing, and that host testing primarily need to be tested with respect to the proof pressure testing or working pressure testing, we have that testing covered under the NABL. Uh, the test laboratory and procedures is laid down with the standard practices. And as you can see, there has been norms which is mentioned as a AS. Those are the aerospace standard testing certification. So you definitely other standards requirement may not be that stringent. So we can definitely cater those requirement as well. So when I say reuse capability, you may probably know in the field where there is a hydraulics and pneumatics, we need to do repeated assembly in the field during the maintenance activity or maybe during the shop activity. So we have the reuse capability test, which is one kind of test where all standard referring to the repeated assembly or maybe make or break, or maybe the reuse capability test. So we work with it. We have the setup. We have all kinds of uh, equipments to see how the performance during the repeated assembly is being measured, evaluated, and we have the understanding of it. So there is a joint strength test. Uh, it is a unique test where we have to pull the test and we have to see how the joint is basically performing. Typically in hose and tube assemblies, the tubular part is been connected to the connectors or fittings, where when fittings is always a different product and tubular part is always a different product. But when we connect it together, the main critical assembly is needs to be tested with respect to the initial joint strength test. So there are different test parameters by which we can carry out the joint strength test, and that is been approved by the AS standard. So it is quite reliable test what we are offering. When I say green, I specifically mentioned the green where impulse test is there. So our impulse test is designed with respect to the keeping in view of the aerospace and defense. So there are other testing standards also where hydraulics and other general application, automotive application is being carried out. But we can do many types of impulse test, which has been widely used in the industry. So wherever there is a green, today's topic is been covered under the green. So you will get to know about all the green in terms of details, how the test is being performed, how the performance is being evaluated, what is the process of testing. So impulse testing is predominantly we are doing from decades now. We have different equipments to carry out different products and testings. So I will take you through impulse test of different types of impulse tests as well. There is a flexure fatigue test. There is a pneumatic proof test, hydrostatic proof test with respect to the different standard as well. Okay. So there are many tests and there are different standard. So we basically keep on adding the scope each and every year. So whatever I'm mentioning over here, those are the covered under the NABL, but there are many tests which may be under they are not standard test, or NABL is not comes under the NABL, but we developed our own fluid control specifications. We can share you whenever there is a need and expectation, and we are ready to develop the customized test program for specifically for your need, whether you wanted to enhance your product capability or whether you wanted to get a competitive advantage. We can develop a test program for you, and we can use our existing laboratory to test that apart from the standard whatever mentioned over there. Specifically, when you see the cyclic endurance test, it is one kind of test where apart from the impulse test, we can test up to the endurance level of the product. So yeah, piped assemblies or tube assemblies, uh, till the failure we can analyze it. We have the laid down procedure by which we can keep on doing the testing, and we can optimize the uh, results in terms of sophisticated equipments as a sensors, and you can provide you the complete analysis report for the cyclic endurance test. So this is one type of impulse test only, but few of the standard call it as a cyclic endurance test. So you can, along with the impulsation, there might be a vibration, or there might be a environmental condition. So that's kinds of endurance test can be possible at our end. When we talk about the high pressure, of course, there is a vacuum requirement as well. So we have the vacuum test setups and associated equipments by which we can create the vacuum, and we can see how the negative pressure also impact onto the joints or specific products. Okay. So regarding the test, so when we start any test, or specifically impulse test, we at least need to see on a theoretical basis how the product is being developed, how it would behave, because that will reduce our prototype testing. So we have a R&D solution by which you can do the entire verification of the product by using the tool called as ANSYS. We have a 3D modeling and drafting experts team, and we have the ANSYS specifically in-depth understanding for FEA and CFD. See what would help to the and this is keep in view that OEMs and specifically manufacturers, there are many things which involved during the manufacturing as well and during the product development stage as well. So we need to specifically select the product material properties, design aspect of it, adding the safety factors. So that can be, and that result to reduce your number of iterations. So when you do the actual prototype testing, maybe your number of prototype testing can be reduced by understanding this FEA and structural analysis over there. So that expertise we built along the team, and yes, we have the practical experienced people throughout the industry. They will help us to develop those products as well. Okay, so this is about the existing test capabilities of fluid controls. So when I say hydrostatic pressure testing, we have the capacity where we can go up to 4,000 bar. So it is a 58,000 psi capacity what we have. Uh, so so that is a pressure testing where you can do the initial proof pressure testing, burst pressure testing. So these test benches, we have multiple test benches through which we can prove the reliability of the test equipment as well. There is a pneumatic proof testing, and in the pneumatic proof testing, we have the capacity up to 20,000 psi, where you can use the nitrogen as a media or maybe the air as a media. Even we can blend the different media together to do this testing as well. Uh, Vibration testing, we have the fixed type vibration, free type vibration testing machine, and even one can test their product along with the vibration. There is a pressure which can be induced into the product, and we can put it onto the test bench where you can see during the vibration also if there is a pressure and what would be the effect of that particular vibration throughout the leakage. So we can understand that kind of scenario as well by using the pressure uh, along with the vibration. Then we have the flexure fatigue testing. So flexure fatigue testing is one type of flexing of the tubes, or you can see that four type of flexing can be possible over here. We have environmental testing chambers like salt spray testing, salt mist testing. So salt spray testing is a normal test, but salt along with the mist is one kind of unique test where you can actually simulate the seawater condition, and we can see the overall performance of the product. Then there is a cryogenic testing. The cryogenic testing, we have the chamber, we have the portable dosing system by which we can dose the required media, which can attain to the minus 196 temperature as well. Specifically, when you talk about the fugitive emission norms, where you need to elevate the temperature or you need to reduce the temperature to the extent that product would be performed under those circumstances, we can do simulate and we can see whether the leakage paths which is coming from which side. So that kind of testing possibility over here. And specifically when we talk about the valves or hoses, there is always a demand that what would be the minimum pressure by which this wall or uh, certain equipments would work. So we have the minimum burst pressure test criteria as well, which has been customized for the specific requirements, and we can do those testing as well. There are many tests like thermal cyclic test by which you can elevate the temperature up to 537 degrees centigrade, that is 1000 Fahrenheit. We do a lot of spring loading testing capabilities of various equipments where there is a springs to be loaded, and spring is one kind of product where a lot of parameter associated with the performance of the product. So we can do the spring loading test as well. And when we developed an installation manual for one of the product, there is a main criteria which comes into the picture is that how you are going to define the torque or minimum force which is needed for the hoses. Yes, standard says certain guidelines to be followed, but actually we need to decode what is the torque level, or what would be the associated force which is needed to connect the hose or tubes. So we have the maximum torque test, uh, and those torques is basically digital, analog, or maybe load style kind of arrangement what we have. So we can tell you to develop the manual by which you can install your product at site. Sorry. Uh, we have the many endurance tests like valve endurance test, allows apart from the hoses and fittings, and there is a high and low temperature impulsation also. So when we say temperature impulsation, there is a temperature which goes down and goes up. So in that simulated environment also, we can pressurize the uh, hoses or fittings or tubes by which we can study the criteria by which product gets failure. And yes, normally chemical hardness for particularly for coating and uh, painting, we have the different testings. Even viscosity test for medias also. There is a oil, and those oils are different oils which acts differently with different materials. So let's say for PTFE or for rubber or for different metals, different oil behave differently. So we need to study the oil criteria as well. So we started with the viscosity. We can do the water absorption test for many materials, and that's what not only the fatigue or failure mode of this, but maybe the media which goes through the pipes, hose, or tubings or valves, that can also be verified with respect to this test. And when we say environmental condition, one test is called as a high voltage test. When there is a polymer material comes in contact with the vibration, there would be a possibility that it would have a elastic current which is getting generated throughout the process. So we have the high voltage test apparatus as well, by which we can analyze the those situation across the product. Okay. So this is the main topic what today's discussion is all about, or presentation is all about. What is the purpose and what is the intention for hose to be tested with the impulsation? So there is a specific conditions or field condition by which you need to meet the product criteria, and exactly that kind of condition is tried to be simulated throughout the impulsation testing. So there are many applications by which this scenario occurs during the life of the product, specifically hoses, and that's define the basically the warranty criteria of the hoses or pipe assemblies. So this left hand side, you can see there is a manufacturer or supplier which always been worried about that what kind of warranty we need to provide to the product, and how, on which basis this warranty is been specified. So apart from the metallurgical or other aspects like manufacturing aspects, so we need to consider what would be the actual usage, or what would be the other factors. Like one of the major criteria which contribute to the failure is impulsation. So there are different impulsation by which specifically hoses undergoes during their life cycle. So we need to see what are the impulse criteria which is at the extreme end hose would experience, and that is the main thing which triggered to impulsation. Uh, so it can avoid your field failures. You can enhance the product life cycle by defining a certain criteria. Of course, there is a standard driven or customer driven approach by which you need to carry out the impulsation. And when, as a customer and end user, always there is a question: if any subsystem or component is being used into the field, what would be the expected life of that particular product? So we can predefine it. We can predefine it with respect to the carry out the impulsation testing, and we can make a benchmarking, or by putting different components together and understand what is the phenomena. Even one can get a competitive advantage by claiming that my hose is performing to this impulsation criteria, and that will definitely add a value to his product or overall marketing strategy. So bottom line is that we need to do the durability assessment by using the hose impulsation testing. So uh, the simple phenomena is that pressure goes inside the hose and pressure comes out of the hose. But the beauty of this test is that how the impulsation happens, and that is main. We need to study and we need to find out the ways. There is always a standards by which we can define, but there is always a demand that this impulsation testing is having very dynamic parameters by which we need to analyze the overall aspect of product which is being used into the field. So, and that will give us the fatigue resistance criteria. So, the fatigue failure of the hoses is the main cause which uh, triggered to the degradation of the hoses. And when repeated pressure impulsation goes into the hoses, it start imparting into the hose material or joints, and then fatigue starts. So initially maybe hose looks very good during the initial testing, like proof pressure testing or pull out testing kind of thing. But when actually impulsation will start, it will give us the correct criteria by which you can define that okay, hose is hose can perform to this much of fatigue life, and that is main concern throughout the safety of the system or safety of the hoses. So that is very essential, that how impulsation behavior of the hoses or overall tube assemblies is to be defined. Okay, so how we do it? Once we are clear that once we decided the test program, how we do it as a laboratory, this is the simple process flow by which we do the testings, not only as a impulse testing, but whatever testings which has been asked to us. We initially do the technical discussion with the end users, clients, or customers. Then commercial finalization happens. Then test process finalization happens. If there is a standard test, then maybe you just need to tell us the standard by which there are almost we covered automotive and aerospace and other standards. But of course, if there is a need and expectation that you need to customize the test specification, we have the experts and we can take the help of you, or maybe end applications to develop the test program for carry out the testings. Then we do the test performance. Uh, we have a software that is a laboratory software by which all the sequence of the operation systematic approach is there. So all sample which comes to us, we define it uniquely, then enter into the lab software, and that lab software is basically assign everything, uh, particularly test center by which it can carry out the test results what is predefined by us. So not only that will give us the confidence that whatever laid down parameters has been set throughout the test, it has been impacted into the laboratory. And then the test performance is being monitored through digitally and also through the manually. We have the uh, across the trained technicians, inspectors, and experts, engineers throughout the test performance time, and they keep on observing the test along with the software as well. So there is a two-way verification. One thing is that software will give us the data, which is quite a reliable data. But apart from that, we have the observers throughout the shifts during the test performance. So that gives us the reliable results. Then once it is been done, we have all the gate reviews. So each and every gate is basically certified by experts. Those are the dedicated experts or engineers, and they once one gate is clear, they give the clearance for the second gate. So across that way, we do the report preparation, and report is also been reviewed and approved by the competent people or enable authorized people by which you will get the report. So it is quite a reliable results what you are getting. Even during the report or throughout the process, we allow certain TPIs to perform the test. Of course, the safety and reliability and other things matter. So we are highly confidential and highly reliable in terms of offering the services. So there is a one software what we develop, and that even can we can give you an ID and password, by which you over there can also see that test is being carried out. So it is need not to be present at our laboratory. Once we entered into the contract, we can give you the password and one app through which you can monitor your test, and that is a AI-based tool, cloud computer tool. So few of the tests currently we have covered under it. So through which you can see that your test is been uh, carrying over the laboratory, and you need not to be actually witness the test. You can even download the report, you can see the results, uh, and that way we maintain the transparency as well. So this is the issue report by which we generally issue the worldwide. It is having the wide acceptance because it is enable, what I say is ISO IEC 17025. That is a global acceptable standard. Okay, so back to the topic actually, regarding the uh, history, how the impulse station started. In 1970, what happened is that there are a lot of hydraulic systems failure, which is been noted uh, throughout the field. And then ISO recommended that there is a test which is earlier, it is basically only limited to a certain extent of the defense and aerospace application. They widely been used for the many automotive and other applications. And then it has been made as a mandatory by the British Ministry of Defense that all the defects, whatever been categorized, it needs to be tested with respect to the fatigue life of hoses, because the hose is the main element throughout the criteria by which you need to see how the hose life is to be defined. So that way, this impulsation comes into the picture, and many standards is basically internationally and nationally has been developed throughout the years, and now it has been matured testing, I can say, by which many failures can be uh, analyzed through the impulse testing. Okay, so this is about the impulsation standard by which fluid control laboratory is accredited by NABL. Okay, so this is ISO 6803. So this has been widely used for rubber and plastic hoses. And primarily, when I say rubber and plastic, the size is limited to 2 inch, where currently our laboratory can test. Even on experimental basis, we can enhance one of the size. But of course, there is a predefined criteria by which we can do the initial feasibility study for particular hoses. It is a standard driven, so we are having limited bandwidth to do the experiments. But yes, as per the 6803, we can do the 2 inch, or in millimeter, it is a 50 millimeter size by which we can do the current testings. Uh, there is a standard pressure requirement throughout the hose specific standard, but our apparatus can go up to 1400 bar, that is 20,000 psi during the impulsation, which is a which almost covers uh, uh, hoses what is being widely used. Uh, we use ISO VG32 to ISO VG100 oil, which has been uh, used and suggested also by the standard, or even we can change the oil with respect to the your requirement. The media, which is demand from the standard as well, and even our apparatus, whatever being used over there, it is having the capability to uh, control their media temperature from 85 degrees centigrade to 150 degrees centigrade. And we have the ambient condition, and also we made a chambers, that is a environmental chambers, uh, that is a 250 degrees centigrade, which maximum we can go, and started from the ambient temperature. Even the environmental chamber, as I mentioned you, we have the cryogenic environment as well. So if any customized demand is there, we can go up to negative temperature as well. But the standard demand about uh, or maybe standards suggest as per the host specification, you need to define your criteria. That's what initially we said, that we need to develop a test program specifically with discussion to you, and by which everything is being imparted into the software and through which test is being carried out. So we have to predefine the all test criteria, because uh, there is a specific host standard by which you need to define the criteria of host uh, specific temperature and host specific pressure as well. And of course, frequency is been standard driven. I will take you through the frequency as well, by which we can offer you the frequencies. And as 6803 is the without flexing, so we have the stationary kind of impulsation test. Along with that, you can see, there is a star by which flexing can be possible with the limited bandwidth. Uh, so if you have specific requirement for the flexing, we can definitely help you to do the flexing along with the impulsation as well. But that needs a certain discussion by which we can define a test criteria. And as per the standard, there is a specific need of flexing. So when like minimum brain radius or many criteria is there by which we can do the flexing. And again, the test apparatus is equal to the above 6803. So media temperature, test fluid, and frequency would be the same as mentioned in the 6803 or whatever specified in the standard. Uh, the below three standards is like SAJ 343 specifically for R100R hoses, and SAJ 517 and 856. There is a bit variation with respect to the temperature and media, so by which we can offer you the testing, and not only related to the hydraulic as a criteria, even uh, before that we can do the testing with respect to the different medias as well. But specifically, this is being made for the rubber and other hoses, whatever mentioned over there as a plastics. So we need to use the media as a hydraulic media. Okay. So certain key parameters, when we define the test criteria, even there is a standard and laid down procedure, we need to define certain criteria, because there are many questions which keep on coming to us during the testings. That what would be the pressure range? So, so there is an increasing and decreasing pressure criteria. Generally, standard suggests 133% of the uh, working pressure or hose allowable pressure kind of situation, where even we can go up to any pressure range. We have the pressure range, as I mentioned you, up to 20,000 psi. So pressure would not be a criteria for, at least for the testing, but one needs to study the standard, and we can also help you to define the testing criteria, or else just simply follow the standard. Standard suggests to go as per the specific hose uh, standard. So definitely one can define the hose criteria of the pressure, and we can go as per that pressure. And the cycle frequency. So when we say the cycle frequency, that is again needs to be defined with respect to the different scenarios by which hose frequency can be defined. The waveform of the cycle frequency is a standard waveform by which we can uh, we need to define a cycle criteria, and the test apparatus is pretty much clear that how the cycle required as per the standard, and we can define that into the testing apparatus. Test duration, it depends on how many cycles and what is the cycle criteria, that is the frequency of that particular thing. So it depends on the that particular criteria. Like example, if you wanted to do 10,000 cycles, then there is a specific duration which we need to define it, and we will definitely give you the timeline before start of the test, when the test will be loaded and when test will be finished. One thing is very clear, that or we need to note it over here, unless and until there is a uh, report which needs to be adhered to the standard, we need to follow the cycle criteria as per the standard. One can customize it with respect to the requirement, but that would be the not the standard criteria. We always has to give the report with respect to the limited pressure cycling. So that's what the test duration is basically defined. if there is a standard requirement, we need to go as per the standard for the pressure cycling, and by which we can define the test duration. Temperature is the standard driven. As I mentioned you, we can go up to negative temperature and positive up to 250 degrees centigrade. Even media temperature is also been taken care in our apparatus. So media temperature as per the standard. Even if you wanted to customize it to the specific requirement, we can do certain changes into the conditions, but it is needs to be discussed prior to testing. One thing is length of the specimen. So as far as the standard is concerned, I have taken this input from one of the standard, which is a selective case for other tests as well, like length of the specimen. So standard is very clear. There is no confusion across the length. So we need to define up to 25.4 mm, that is precisely 1 inch of the hose. So we have to calculate the overall length with respect to the formula, and by which the minimum length of the hose shall be fall into that part, or precisely we need to go as per the standard. Uh, when we demand the test specimen, I think whoever may be the main hose manufacturer or whoever may be the supplier of the hoses, we can suggest them what would be the length which is specified in the standard, or they can also refer to the hose standard and they can give us the hose to the specific standard. Because as per the NABL guideline as well, and as per the laboratory practices, we need to measure the hose with respect to the standard. So if hose is not meeting with that criteria, we cannot put it on the test bench unless and until it is been given a written permission and it is to be deviated with respect to the written permission from the customer. We cannot deviate, or maybe the report would not have that particular standard mentioned into the final results. So that is precisely we need to select as per the key parameters like pressure, cycle frequency, test duration, temperature, and length of specimen. This is extremely important before the test. So either you can provide us the entire thing, or we can together jointly discuss and can define the phenomena for the test specimen. Okay. So this is the test apparatus. We have many test apparatus, maybe 3 to 4 test apparatus by which we can do the testing. This is one typical example of the test apparatus. And you can see there is a tank which is filled with the specified oil. Then there is a relief valve arrangement is there. There is accumulator which maintains the pressure criteria, predefined pressure criteria. We have a proportional servo valve by which we monitor the pressure what is being set, and these are all programmable kind of thing. Even for standard specification, we already predefined the program for certain standard sizes with respect to the length, but to the specific your criteria, we can do little bit modification with respect to the before putting into the test apparatus. Then there is a booster cylinder and there is a directional control valve, and then we have to put the specimen by which results is being monitored. And this is kind of closed loop system. Even once we kept into the chamber, it is not been allowed to tamper with those samples, and it is completely sealed, and we even can put a lock over there. You can see there are certain locks arrangement which has been provided onto the handle. Even when we offer it to the third party or witnesses, they basically seal this chamber, and test is only monitored through the visual window and with respect to the um, desktop monitoring system or pressure or temperature sensors. So it is completely a uh, impartiality clause what we uh, offer to the clients, and reliability has been guaranteed over there. Okay. So we saw a test rig, a schematic diagram and photograph as well. So, the main thing when we see about the reliability of the test, the reliability has been defined with respect to the pressure control system. So we use the uh, best of the best pressure controlling system by which throughout the pressure controlling system is being used. So
एक ना सेमिनार हो रहा है, ठीक है, इम्पल्स के ऊपर। हेलो। एक सेमिनार हो रहा है.
Okay, sorry. I think there is a bit disturbance. Okay, no problem. Pressure control system. The system that uh, we design with respect to the best of the best industrial control systems. But of course, along with the pressure controlling system, there is a sensors, and those sensor is monitored through the data logger system. So when we say a data logger system, we studied across all the different data logger systems. We have even few of the data logger system which is being used in the very renowned laboratories across the world. We studied it, and then we developed the data logger system. Then that data logger system speaks to the sensors, and there are different sensors like for pressure sensors, then strain gauges, displacement sensor, RPM sensors, and RTD sensors. So this data logger sensor is a unique sensor system by which you can measure different types of parameters, and that is also been calibrated with respect to the certified traceability chain throughout the requirement of the NABL. Even when we initially uh, verified the test apparatus, we tried to develop a unique traceability system, and we successfully done it, and we demonstrated it to the computable authority like NABL, where 17025 criteria, that is international criteria, been applied, and that is basically a reliability and reproducibility. So we tested with respect to the predefined samples and evaluated all those criteria, and nowadays you want to say TPIs and many customers verified that test apparatus also. So we are confident enough that whatever calibrations or whatever uh, validation is to be carried out as far as the test apparatus, we uh, we proved that test apparatus is meeting all those criteria. So this is the okay. So this is a typical waveform. As I mentioned you, when we say the frequency, this whole waveform is been this is the representative waveform from one of the standard, but all standard is maybe similar to it, or maybe there are little bit changes into it. So our sensors or whatever mechanical arrangement or pressure arrangement we have made so far, that can generate a square, trapezoidal, or rectangular waves that is being required over there. You can see there is a peak curve by which you can go up to that particular 1.33% of the pressure or predefined tolerances, and then we can have the sine wave when the pressure impulse is in progressively going on. So there is a complete system by which you can also visualize that okay, this impulsation is started from when, what is the criteria, and how the one cycle is defined, and it would keep on continuing as per the standard. So this entire system is been covered under the data logger or various sensors. So we precisely selected the sensors and placed uh, uh, through a mechanical arrangement or the apparatus arrangement suggest us to put it over there, and this has been completely verified and validated throughout the repeatability and reproducibility clause. So we can generate these kinds of waveform, and even before actual test starts, if one wanted to study it and one wanted to define a specialized waveform, we can definitely try to meet your subjective requirement. But as far as the standard what we covered, it covers almost all types of waveforms which is been suggested by the standard requirement, even general and industrial standards, and specifically aerospace and defense standard as well. Okay. So duration wise, as I mentioned, there is a no specific criteria for it, but as per the standard, we can go up to any cycles. Even we carried out recently 10 million cycles as well for one of the hosts. So that is not a criteria for us. Only thing is that we need to define how the test sequence and how the test to be performed along with the sample selected. Evaluation criteria, as all of us knows, that we need to do the physical and visual inspection of the hoses, and of course there is a pressure arrangement already been there, and the pressure sensors are there, so one can verify by using the pressure data as well. Typically standard basically suggests us with respect to the pressure cycles, you need to monitor the pressure drop or any visual leakages over there. That can be pretty much possible throughout the test. Okay, so as input was there, okay, we need to define the hose life cycle. We need to see how the hose perform with respect to the impulsation. What are the benefits? Okay, so reliability is one thing. It guarantees that hose can endure real world pressure. So once all impulsation test or associated test is been carried out, one can definitely guarantee or warranty that product is quite reliable. You can use it to the specified requirement. We can do the failure prevention, and of course, as far as the compliance part is there, so there is a mandatory requirement by the OEMs or system integrators that hose should undergo this much of testings or impulsation, and we are pretty much assured that hose has been tested with respect to the laid down criteria, so it can perform very well. And we can one can, apart from the specified standard, one can uh, design the specific hoses, and one can take a informed design decision throughout the impulsation testing that my hose needs certain improvements, or my hose is specifically not over designed to the required standard. So that way we can definitely give you the feedback about the hose development stages. So these are the applications in automotives, mainly fuel hoses, coolant, brake system hoses, hydraulic hoses, having the demand to subject to impulse testing. So in specifically automotive is the more demanding sector in terms of impulsation, because the environmental conditions for the automotive is nowadays speed and all those environmental condition impacting the performance, and as well as to optimize the cost, one cannot over design the product just to sake of that condition. So one need to be precisely optimize their product in those applications. So automotive predominantly defined a lot of design aspect and throughout the impulsation requirements. So many OEMs, and we tested almost all OEMs parts, majority in the India, and we know their specification as well. So our laboratory is to the tune of their specific requirement, even for the two-wheeler market, four-wheeler market, or maybe the off-vehicle market. So we know what is the criteria. Even we can discuss with you, or maybe whoever may be interested to meet their specific requirement. Specifically for the OEMs, we are pretty sure that we can discuss with their designers or process engineers to develop certain criteria. During the developmental phase only, we can able to define the criteria, and we can do the verification and validation of the testings. And there are many hydraulic systems in heavy machineries, in hydraulic systems, and even for the small lifting arrangement, that is also having the hydraulic power packs and criteria where impulsation can occur. So instead of going for a standard practices, we can define the criteria, and we can do a customized testing to the specific requirement that one can guarantee or warranty their complete apparatus with respect to the certain criteria. So that is pretty sure that this can be possible over here. And of course, aerospace is one highly critical or demandable application for the quality. So our test apparatus has been designed in such a way that even being used by the many tier one supplier of the Boeing and Airbus, they used our facility they tested their products to us. Even Indian Air Force and Defense has been uh, witnessed the test parameters over here, and we certified that kind of hoses as well. So we are pretty much sure aerospace is one segment where we can do the testings, and of course oil and gas and firefighting system as well. So different applications, even the hose is same, their demand and their standards are slightly different. So one cannot refer to one standard to the another. Maybe that would be similar, but we try to put our utmost effort to accommodate all those standards together, and we blend our test equipment to the tune of all those standards. And that's is the versatility what we are offering in terms of testing those hoses to the multiple standard as well, if that same hose can be used to those requirements. So it is not only industry specific, I can say, rather than industry specific, one product, if it is pretty sure that one manufacturer or one system integrated want to see whether their hose is been uh, hose can be tested to this standard or that multiple standard, yes, we can do that experiment as well. Of course, the hose manufacturer needs to differ those specific hose construction and hose design, and we can do the testings and we can certify you that okay, this hose can be used for many applications. Predefined condition, it should meet the specific application for the construction and design. Testing, rest assured that we have the testing apparatus, and we can help you to design certain test parameters which can certify to the multiple application. So these are the few examples by which we tested the piped assemblies and hose assemblies together. Uh, so here you can see this is air-cut refrigerated self-seal brass couplers. This has been tested with respect to the pressure impulsation. This is radiator intake hose. One can see there is a very complex hose by which the even attachment is quite challenging for us. When we were testing these hoses for the impulsation, the attachment is been designed and developed by us. Even we developed the test program exclusively along with the one of the OEM to validate this, and now it is been as part of their test specification. This is the CDI fuel line. This is again the one of the application where we carried out the endurance testing and up to 10 lakh cycles with frequency of 10 hertz. And you can see there is a slight white kind of stains over there. It indicates that temperature is from -20. So we could able to simulate through a media, and where we tested the piped assemblies from -20 plus 120 degrees centigrade as well. This is specifically oil hose pipe. So you can see there before actual fitment onto the oil pump, this hose, complete hose set of hoses is being tested onto the rig. This is cooler transmission hose, which needs a certain criteria of maximum temperature, so we tested it. This is a particularly Honda Civic steel braided fuel hose, and those standard attachments over there by which we attach those connectors through a manifold, and then it is being tested. This is a PVC make up air line. This is the turbo AC air conditioner. So here you can see -30 also can be simulated. There is a white spots which is coming onto the hoses, and we taken it a picture throughout the window camera. So one can see that actual all those things is been colder than the -30, and we can test this. This is impulsation along with the pressure test. This is the car and truck oil cooler hose with the ambient temperature. These are the few of the example for fittings. So fitting is a one thing which is attached to the pipe and manifold. So this is the unique combination by which there were a lot of failures which has been recorded not only as a hoses but as a unique assembly. There were a lot of failures which they have noted during the application. So they came to us and we developed a test rig for them, and we could able to evaluate what would be the failure mode, and we given them the complete solution with respect to the temperature as well. So uh, see, when we do the testings, specifically not only the pressure impulsation, but environmental and corrosive conditions uh, changes the fundamental property or design criteria of the fitting and hoses. So one need to be very precautionary, uh, uh, select the particular criteria, and that's how we can do the simulation. So that way we can design the test criteria apart from the standard, and we can do the testings. So what are the challenges which comes under the during the impulse testing? The main criteria is complexity of the testing. So there is always a unique demand which comes into the picture. Okay, what would be the real world condition? So we are trying to simulate those conditions, and we are quite flexible to simulate that condition. We made the apparatus in such a way that one thing is that we can do the standard testing with respect to the laid down practices, that is pretty sure. But when there is a complexity apart from the standard, or one can to optimize the effort, we need to design the number of hoses to be tested. Standard demand certain sample size or specimen size, but we need to also give you the benefit with respect to the curtail the not only the cost but also the timeline of the testing. So we define the test criteria, and that is where the complexity comes into the picture, and that's basically give you the overall effect of reduction of the cost, not only as a sample testing cost, but you can reduce the time. You can take you can penetrate into the market well in advance by using that kind of cost benefit, and that way we can identify the failure modes much before it is putting into the action. Crucial when we declare the results. Uh, this is the combination of the hoses and fittings all together. So one bare hose is cannot be tested together. So crimping, overall process development, that is very crucial into it. And many times what happens is that hose may be okay, but the crimping criteria, even fitting may be okay. So entire set of assemblies needs to be go together. So one needs to be very precautionary, clear that all this set of specimen needs to be intacted with respect to the requirement. And that's what we face challenges, that sometimes fitting is being procured, our fitting combination with respect to hoses is not being selected properly, and that is basically the main failure modes by which hoses gets failured. So before putting into the hoses, it is mandatory required that all this testing, and even standard also force us to do those testings. So at least bare minimum all those testing needs to be carried out before putting into the impulsation testing. Of course all people take care of that, but that is the main requirement before putting into the impulsation chamber, because impulsation is a long duration test and complex test as well. So one needs to be take care that all test is being suggested by the standard is being taken care, and then we have to put it in the impulsation. So failure mode is chances are minimal. Even the fatigue testing is having their own requirement, that we need to define the impulsation testing procedure. This is one of the example. As per the ISO 6803, you can see when we provide you the test report consists of all the sample details along with the uh, uh, identification, and the name will come over there. Then there would be a equipments which is being used throughout the test and their associated calibration records. Then we'll give you the test criteria and the pictorial diagram of the sample along with the waveform. So this is one of the example. There are different test report by which the test is being carried out. So it would be a bunch of all those requirement. It is as per the laid down practices of uh, issuing the results. So all compatibility and all the associated technical experts signs this report. So results and report is very much been accepted by the TPIs and many OEMs. So fluid control report is one thing which you can show it to the customers or OEMs, that we are pretty much sure that it would be acceptable. We take care of all those minute details, whatever is needed or expected, not only from the standards, but also from the manufacturer or customer point of view. Okay. So before going to the question and answer, there is a short video about the facility. This is a 5 minutes video. So let me run through a video, and then maybe we can open for the discussions. दिसतंय का? Escape করতে হবে। শুভ্র?
Thank you, Rahul sir.
Okay.
And
So thank you for
Yeah.
all patiently listening me. So
thanks all the participants. And in case you have any question or queries, you can ask your question to Mr. Rahul Patil. Sir, one question is from Mr. Raju Meharwade sir. Can
Yes.
fluid control perform impulse test for fittings as per ISO 6605? And what is
Yes.
the timeline for 1 million cycle and what is the waiting period?
See, one thing is very clear. Yes, we can do the testing on the fittings as per the standard. Regarding the timeline, we need to define the test program. As I mentioned you, we need to see the number of samples, then size of the fitting. According to that volume, we have to calculate the time. But yes, uh, we have the different apparatus through which we can define the cycle time, and we can do it, no problem at
One question is from Mr.
Sir,
A.K. Singh.
my question is,
Yes,
sir,
all. Yes.
yes, please.
sir, do we have any accelerated test for impulsion testing? Because two of the customer they require the results on urgent basis. Since we are going
Uh,
for IATF and AS also, it is a mandatory requirement. Most of the customers they are asking for the impulse testing. So, do we have any accelerated test within day or 2 days? We'll get
No,
results.
no. Actually, impulse test itself is an accelerated test.
Correct.
It's an accelerated field test. The
Yes.
result which you can
No,
expect
you're
after
talking
1 year or 2 years, you are getting in 4 5 days. You cannot accelerate it anymore.
of
I'm sorry. There is no accelerated test faster than impulse test in this world, as far as my knowledge goes.
No, and yes, Amriji, I think it is right because
Your
it is.
agencies, your clients got to take a little bit of patience. You
Mm.
cannot have anything faster than impulse test.
I understand, sir, but you see, it's up to customer only. Because
And a
suppose
customer
customer wants
customer is God, but it's not
Ah.
beyond God, yeah? And even God cannot accelerate this test. So,
But
Okay, okay.
or else it would not be the standard test. If you
yeah.
don't want to be a standard to be
And
mentioned
you
on the
can,
report,
instead,
and you
yeah,
wanted to do the customization of anything, then we can do the
see,
experiment. But it is an experimental study which we need to carry out.
yeah,
It is not as per
actually,
the standard.
if you see, if you want a 1 million cycle test at say 60 cycles per minute, you can really ask, your customer can ask at a say 30 cycles per minute for 1 lakh cycle or 2 lakh cycle. That can be, but then there is very difficult to draw an analogy to 60 cycles per minute and 1 million cycle is equal to 30 cycle per minute to how many million cycles? It will be a debatable thing. For that, you got to go in for real R&D.
Yes, sir. Thank you. I understand now.
There was a question for SS corrugated hoses. Can you please check it?
Navneet? Navneet?
This from Navneet, no? I think can you do in-house impulse test for SS metallic hose according to AS and IITF?
No.
Yes, sir.
It was from Mr. Raman Deshpande.
Yes. Myself only, sir. We are into the
Yeah.
manufacturer of SS. The sizes, in fact, I asked for the size also. What is the minimum diameter, maximum diameter which we can do, and what is the length? Because suppose since we have to do the testing on samples. So sample preparation is one thing, and what is the diameter, minimum diameter, and maximum diameter which we can do? That was my question, ma'am.
Yeah, that they need to check the volume, because if it is a larger size, then they need to go for the volume intake of that particular size. You can tell your sizes. They can give the feasibility accordingly.
Okay. Yeah.
Yeah, Mr. Navneetan also had some query.
What a minimum size can we test? I think Mr. Navneet is asked about the SS metallic hose, right? According to AS and IITF. I think it has been answered, but Mr. Navneet is there?
I still not there.
Yeah, Mr. A.K. Singh do have a question. Does fluid control has any franchise model to enhance its most reach across the country?
Ask the question. That's not what I came up. He was asking me, where is Navneet? He was asking me questions. You don't ask the question.
Of course, one need. I think regarding the franchisee model, of course, we need to discuss together. We'll invite you to meet us, and then maybe we can take this further. Of course, SPP index can help us to make that connect.
Maximum. Second thing I ask about your question.
Sure, we'll take it. So any more questions from the audience, please? Participants, please raise the questions if any, if further.
Yes, Mr. Navneet, Mr. Navneethan, any question is there from your side?
Yes, sir. Yes, sir. Good evening.
Yeah.
Regarding that impulse test, shall we do the impulse test for the SS metallic hose also as per the 10380? 10380 does not mention about the impulse test.
See, for us, for metallic hoses, we need to check the standard, of course.
Yeah.
But yeah, we can do the testing. Testing is not an issue. Only the hose should suggest, the hose standard should suggest to carry out those testings. As a apparatus point of view or as a laboratory point of view, we don't see any problem over there. We can definitely can carry out those testings over here. But one need to test the standard. And if you really wanted to uh, uh, customize it to this specific of application, we can discuss and we can define the test criteria. But
Yeah.
as a laboratory point of view, it is possible. It is pretty much possible.
Yes, sir. As per the standard 10380, ISO 10380, that is meant for the SS corrugated flexible hoses. This does not call for the impulse test, but some of the customer, like some aerospace customers or OEM customers, IATF customers, are asking for that impulse testing as the specific requirement for the metallic hoses.
So maybe I see one thing is not all things is the standard driven. Maybe certain OEMs or system integrators define their own criteria, and we can do that testing as well. We need to know the overall requirement, and we can do it, no problem.
What is the facility available for the minimum and maximum sizes, sir?
Minimum, I think we don't have any issue. Maximum is up to 2 inch we can do, and there is a specific standard for carry out the impulsation for aerospace. If you really wanted to, I would say, if that standard you wanted to perform it, we know the how to carry out those testing to the tune of aerospace requirement. There is a specific aerospace driven standard by which you need to carry out the impulsation.
Okay, sir. Okay. Thank you.
Thank you.
Mr. Navneet, there is one more standard for this SS corrugated, that is ISO 7369 something. Do
Yes,
that
sir.
have any impulse test mentioned on that?
Oh, in the standard that is 7369 also is not having that impulse test. It's 10380 is there, as well as the BS 6501 is there, and 7369 also is there for the stainless steel metal corrugated hoses. But there was no specific requirement for the impulse testing.
Okay. Okay, then. Yes, any more questions, please?
Hello?
Navneet.
அந்த ஒரு 10 நிமிஷம் பிரபு ஒரு இது போயிட்டு இருக்கு. நான் சொல்றது
Navneet.
virtual meeting போயிட்டு இருக்கு ஒரு 10 நிமிஷம்.
Any other question? Okay.
Navneet.
Yeah.
What is the cost of the impulse testing machine approximate?
The equipment price of the impulse test.
Equipment.
If you are asking me, I think we don't provide the impulse testing machines. We don't manufacture the impulse test machines.
No, but
We-
approximately, I'm telling, asking you.
No, it's very difficult question for me to answer it in a
Say,
straight
yeah,
way.
a standard version of impulse test machine from Bimal or someone, it costs anything above 1.5 to 2 crore to about 6 crore.
Okay.
So, and that also have a limitation of temperature and pressure resistance. That is maybe up to 700 or 800 bar, and temperature up to 120 or 130 degree. Okay. So every machine do have a limitation, but in fluid controls, they have developed the machines, they have developed the data, they have developed all the technical. It is a customized machine.
Even though we are having the positive temperature as well as the negative temperature also, na sir.
Yeah, this machine to have a negative temperature up to 80 degree and a positive temperature up to 250 degrees, which is a maximum.
Okay, sir. Okay.
Mr. Rahul, Mr. Nitish.
Yes. Yes.
Mr. Rahul, this question.
किसका हमारा है उनका है किसका हमारा है उनका है
I'm just asking with Mr. Rahul. Please clear me about acceptability.
Sorry, sir. I am sorry. Pardon me, but your voice is bit. I'm not able to audible the last words.
Just please clear me about acceptability of your reports in terms of PSUs.
Okay. See, we tested the IOCL along with the IOCL. We tested the hoses for specifically few of the fluids. Then Indian Railways basically accepted our hose reports, and there might be many names. I cannot I cannot recall all those names, but yes, almost wherever we worked as a or our clients worked with the PSUs, they provided our reports and they accepted it. If you need, I can share you on the email whatever is there. Okay.
Singh sir, see, this facility is a NABL certified facility, so PSU should not have any problem.
Okay. Thanks, Anup.
Okay.
Thank you.
Any more?
No, sir. Thank you.
Thank you, sir.
If anyone has any other questions from Dr. Rahul, you can always shoot a mail to any of our FCP Index member, and we'll try to get you the best answer for that.
Yes.
Thank you, everyone.
Thank you.
Yes. So, Nitish, can we conclude?
Yes, sure. Thank you, Rahul Patil sir and Mr. Ganesh Lohar for such an insight session. And in case any queries or questions are there, you can directly send your queries to info@fcpindex.com. So our next knowledge sharing series session will be on 25th of January. We will share the topic of that session in next few days. So we will be like having recording of this session, and we will be putting this recording on the YouTube channel also. So we will share the link of YouTube channel also in next 2 to 3 days. So thanks, Mr. Patil and Mr. Lohar for this knowledge sharing session. Thank you. And thanks all
Dr. Patil. Thank you.
So thank you all participants, and on behalf of fluid control, I thank the
FCP
FCP
Index
Index
and
and
Assemblies.
Thank you.
Vijay and
Thank you.
Anupji
Bye.
for
Thank you,
connecting us.
sir. Thank you.
Thank you all.
Bye.
Thank you all. Thank you.